Second one? Okay. So we're going from 2 to 5. So what's the first function? Minus 0. So we're just going to get rid of it. So I get x thirds x cubed over 3 minus 4x from 5 to 2. Yep. Do you want me to show you the math for the first one? Okay. I'm going to put it up here though, because I already kept writing. Okay, distribute the negative. So the integral of negative x squared minus plus 4. So I'm taking the antiderivative, so I have negative x cubed over 3 plus 4x from 0 to 2. And we just plug in the values. So negative 8 thirds plus 8. And that should get me 16 over 3. Yeah. Any questions, Kalisha? No. Okay, anyone else have any questions about how we got 16 divided by 3? No. Okay. Second one is a lot easier.
Yeah, I took them and I got 65 thirds. Yes. And then negative 16. Yeah, so you this should it would be plus 16 because it's a negative. You said it's a negative 16. Yeah.
Do we get an answer of 27 units squared?
There's 2 of you in class who probably don't have calculators, because I have 2 calculators up on my desk. One of these.
Okay, I'm going to ask again. Do we get 27 units squared? Thank you for responding. Thumbs up, thumbs down if you got it.
You got me there.
I saw the same Nemo. So it's for you.
Instead of writing my And that's one we already did on part one. So it's supposed to be-
Someone said that to me.
And that's fine. Angel, we talked about joy in this class, right? The other one, what's the second? Okay. Now we have this different perspective. I think the.
One word of this man is like
Calculators get me. I don't like you guys' calculators. Mm-mm.
Sebastian must be using his phone. Oh, stupid. This is so embarrassing.
It should only be for the second area before we add them together. I could be wrong. Who got 27? Okay, let me see your calculators. That was a lot. Yeah. Oh, you're adding them.
Why are there so many 27s? I don't know how I did that. I didn't even do that. Did I just enter? This, I would just.
Yeah, this kind of turned into plus 60.
Okay, what do we do to our two areas to get our final area? Add. What are we adding? Cleisha, what are we adding? Yeah, okay, 27. Yep, 81/3. Okay, what do we get for our final answer? About. And what's our label? Yep, or squared units, either way. Units squared. So adding the areas. Okay. 1, 2, 3. How hard was that? 3 really hard, 1 easy. Yeah, I would watch the video. We did a little bit more. Everyone needs to participate. 1, 2, or 3. How hard was it? 1 easy, 3 hard. Okay. Thank you for almost all of you for participating. It's going to start going towards your participation points too, by the way. Okay. Thank you. We're moving on for a little bit. We'll circle back to this at the end if we get to it. Now, we're going to take two functions. We're going to change it up a little bit. Let's say we have function 1. That's not the function. That's the x-axis. Yeah, we are. Yeah, two functions. What's wrong with two functions? Mine's a little wonky, but it is what it is. Do these satisfy the vertical line test? No. How about horizontal? Horizontal. So I'm going like this way. Oh. It likes to do that on me. This way. Does each input have one output? Yes. Okay. We satisfy the horizontal line test. So we're going to do the integral. Not based on A and B, but C and D. Horizontally. So our bound is going to be horizontal bound. So we're going to find the area between these two curves. It's going to look like this area right here. Oops, this is going to be too big. All of this area. All of this area. So integral is going to look somewhat the same, except we're changing it with C and D. I'm going to write the first function as x equals f of y, and our other function as x equals g of y. Which one is the greater function? Is f of y greater than g of y, or the other way around? Which one is greater than the other? The blue one? The green one. Okay, I don't know why. Did you say blue, or did I just hear it wrong? Yes. So we're still writing our area integral as c to d, but this is now f of y minus g of y. And should I put dx at the end? Yep, dy. So integrals of y. Do you want to do an example together, or one up on the boards, and then do a harder example to get on the boards? Okay. Let's do an example. Let's take two functions. Let's call this x equals y plus 2 and x equals y squared. This would be f of x. Let's call this, let's not even call them anything yet. Those are just our two functions. We're trying to find the area between those two functions. Find area bounded by the two graphs. Find the region bounded by these two graphs. Okay. Do you know what these graphs look like? Yes. Opened which way? Yep. So it's a parabola, just open to the right. Oops. Something as such. Why did I draw all the way out there? Should be touching the origin. So that's one function. Okay, if this is hard to graph in your head right now, you can also just switch it around to y equals x minus 2. If that helps you graph it. What type of function is this? Linear. Where should we start? I hear so much whispering and I can't hear any of you. A little bit louder. Positive x up here? Or negative? I think negative going up. Kalisha, do you know the bounds that we're trying to find right now? So I'm trying to find the area in between. So kind of like, I'm gonna draw in pink, maybe, if it lets me. Trying to find all of this area. So I need to find the points that they intersect. So I need to find this point right here, if it lets me, this point right here, and this point right here. How do I find those 2 points of intersection? Should take my 2 functions and do what? Yeah, I think you all saying it, but I can't hear any of you guys. Set equal. Set equal to find bounds. Find C and D. Okay. I would do y plus 2 and y squared. They both equaled x. Okay, find my bounds. What's the first thing most of you guys want to do right now? Okay, do I have any like terms? What can I do to those two? Want to do that? Okay. You can also minus the 2 on the other side. Okay. What's next, JJ? Riley, what's next? How do we find what y equals? Mm-hmm. So it's with an F. If I factor this, what do I get? Say it again? Yep. Y plus... Plus 1. Okay. Y equals 2 and negative 1. So we got our bounds. We have negative 1 and we have 2 up top, which, funny enough, I already put up there. So we got area equals integral negative 1 and 2 of dy. Okay, which graph should we put as f of x? The first one. The graph that is greater than g of x. Which one is greater than the other? Yes, why?
Because it's like further to the right.
Y plus 2, yeah. So this would be f of x. And this is g of x. Any questions about why f of x? Or why the y plus 2 goes first? No? Okay. Y plus 2. Plus or minus? Minus y squared. Find the area in between these two graphs. Okay, we only have 1 second left. But 4.5 squared units should have been your answer. Did we get this answer? Or we're still working towards it? Thumbs up if you did. Okay. Okay, before you leave, take a picture of this. This is going to be your homework. Gotta do it by the x-axis and the y-axis. I don't like that word. You have one problem, and then we're gonna call it a day on finding the area in between two curves. What? Okay.
Well, you have to remind me because I'm gonna forget.